Okay. So this is the last section before we take a quiz. All right. So we will take the quiz on 2.5 and 2.6. I guess. What's today? Wednesday? Yeah. So we'll review tomorrow. We'll take the quiz on Monday. I know the marking period's over tomorrow, but there's still enough time for me to get the grades in. So we'll take it on Monday. Make sure you're here, please. Don't miss. All right. So that it's just a pain when you miss like the last assignments before marking period, because then they want the report cards and you got to get stuff turned in. So make sure that you do that and that you're here. All right, here we go. We're going to graph inequalities. Inequalities. So these are things that are not equal. You've actually graphed inequalities already. I don't know. Did we do that in here? Did we do this? Did we do like this? Just the number line. We did that. Okay. And if I said x is greater than or equal to -2, how would you have graphed that? You put a -2 right there, and then you would have a closed circle and everything shaded where? It's greater than to the right, right? So we have graphed inequalities before. You have graphed inequalities. You did that in Algebra 1, I'm almost positive. Would you agree? You probably did not do what we're going to do today in Algebra 1. But they're still inequalities, and we're still going to graph, right? But we are going to we're going to graph them on a line like this, on a Cartesian plane, a rectangular coordinate plane. So here it is. It'll say to graph. Now, guys are Algebra 2, right? Yeah, we did this in, I don't know, maybe we did. Did we do this in geometry last year? We may have. I bet you we did. I just can't remember off the top of my head. But it doesn't matter. I'm going to teach it to you from scratch anyway, even if we didn't do it last year. All right, so here we go. Do you remember with inequalities, you keep the inequality the way it is until you do what? By a negative, right. If you divide by a negative or multiply by a negative, then you would change the direction of that inequality. We talked about this year, didn't we? Yeah. So it's the same thing holds true. But if we want to graph something, this has an x and a y. So how are we going to graph something that's got an x and a y? Before, that graph that I just erased, it only had an x. Okay, x is greater than, x is less than, whatever. Okay, but this has an x and a y. So we're gonna do this just like we just as if it was an equal sign. All right. So what would we do? We'd put it into what form? Slope-intercept form, except it's not going to be y equals mx plus b. It's going to have an inequality. All right. So basically, we're just solving for y. That's what we want to do. That's our first step before I even think about graphing. So let's solve for y. Let's get y by itself. So what am I going to have to get rid of? The x. Move the x over. Okay. So move the x over. So what am I left with? Just a y? No, a negative y, because it's minus y's. And I'm going to move the x over. How do I move that x over to the right side? What do I have to do to that? Minus it. Right, subtract it. Subtract an x from both sides. So I subtract an x from this side. And I just push that -2 over to the right a little bit. I want that x first, okay? I don't want to go -2 minus x. I want negative x minus 2. Everybody good with that? Yeah. And then one more thing, and I get y by itself. What do I have to do to get y by itself here? Divide by -1, right. So if I divide this by -1, I get a positive y. Now, I'm dividing by negative. What did we just say a minute ago? You have to change the inequality. That's right. So I got to change from greater than or equal to less than or equal to. What's going to happen here? If I divide this by a -1, I have to divide this by a -1. That gives me positive x, and I have to divide this by -1, which gives me plus 2. All right, I didn't really show that step, but we talked about it, right? You should be able to just go from here to here. Everybody good with that? Yeah, that's pretty basic algebra stuff. Okay, now what we're doing today is we want to graph it. And we're pretty much going to graph it the way you would if it was an equal sign at first. All right, then we're going to add a little to it. Pretend it was just y equals x plus 2. What would you do? How would you graph it if it was y equals x plus 2? Go up to 2. Very good. Y-intercept. And what's the slope? It's 1. So it's positive 1 over positive 1. So I'll just put a few more points in here. Boom, 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 right to here. And then we'll go here, 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 here. I'm just going to go all the way to the end like that. And then you just connect them like this. Now, you got to be careful before you draw that line. Let's talk about that a second. Now, I drew a nice solid line, and that works with this, but here's what you got to do. You got to look at this. Remember when we did that one just went horizontal? If it said or equal to, what'd you do? You filled in the circle, correct? Okay? So this right here means every one of these points on this line are filled in. So it's a solid line. What if it just said less than and didn't have or equal? You would put a dash line. That's right, a dotted line. Everybody hear me? If it's, here, let's write it down. If it's, I'll just put greater than, oops, make it go underneath. Greater than or equal, less than or equal. Anything or equal is going to be a solid line, okay? Just like this one is. What if it said just greater than, or it said just less than? Then they would be dashed, okay? I'll call it dotted, is that all right? Same thing, okay? Dash line or dotted line. That's really important. I will mark the problem wrong if it's supposed to be solid and you make it dotted. But most people have the issue of making it solid when it's supposed to be dotted. All right, that's where most people go wrong. So write that down somewhere. Remember it. Don't get mad at me on a quiz or a test if I mark it wrong. Oh, Mr. Hammer, come on. I hear this all the time, believe me, when we do these problems. Mr. Hammer, how can you mark that wrong? The graph's right, I shaded it right and all this stuff, but it's just because it was supposed to be dotted? I'm like, yeah, that's what I told you, okay? But is this one solid or dotted? It's solid, okay? So I'm good writing a solid line here. Everybody good with me on that? Okay, remember that. Write that down somewhere. Hopefully you wrote that down so that you remember that. All right, now we're not finished yet. It doesn't say just y equals. It says y is less than or equal. All right, so there's a lot of values that if I choose a point, x and y, that the y will be less than whatever that x is plus 2. And there's a lot of values that it won't equal. So how in the world do I know which ones work? Well, what I can do, we're actually going to shade. We're going to shade a region. Do you remember doing this in geometry? Okay, where we shaded a region. How do I know which one to shade? Do I shade below or do I shade above? Well, if it's less than, what do you think? What's your thought process? You probably shade below. Sometimes when that line starts getting a little more vertical, some students have a hard time figuring out which one's above, which one's below. All right, because it starts getting a little more vertical and you're not really sure. All right, so here, this is a surefire method to figure out which area do we shade. All right, what we're going to do is we're going to pick a point, any point, it doesn't matter. All right, don't pick a point on the line itself, that's not going to help you. Pick a point either above the line or below the line. Now, here's a hint. Here's the easiest point in this situation anyway. Here's the easiest point to pick. I would pick 0, 0. Just because it's easy to do the math. All right, I could pick any point. I could have picked this point over here, 7, -5, or whatever number that is. Okay, I could have picked that. But what would you rather put into this? Would you rather put in 0, 0 or a 7, -5? The 0, 0, obviously. Okay, any point below here. If 0, 0 works for this, then any point on that side of the line will work for it. I'll show you. So let's put 0, 0 just for an easy point. So let's put a 0. Now I'll put a question mark because I'm not sure just yet, okay? And let's put a 0 in for x. And then we put plus 2. Now what do we get? 0 and this is 2. What is 0 compared to 2? It is less than, okay? So does it fit? Does it make this inequality work? Does it satisfy the inequality, as a lot of times they say in math? It does. It makes it work. So 0 is less than 2. So putting 0, 0 in there made it work because it is less than, right? It's not equal, but what's the word? It's less than or equal, right? So it is one of those, isn't it? All right, so that works. That means I could shade everything in that region. With me? Let's pick another easy point. Like 1, 1. How about that? Put a 1, 1. Let's just do that in our head. Put a 1 here and a 1 here. So is 1 less than 1 plus 2 is 3? 1 is less than 3. Yeah, it works, doesn't it? Any point that you pick on this side of that line will make that thing work. Let's try a number on the other side. What should happen if we pick a number on the other side of that line? It's going to make it not work. Okay? Would you agree? All right, let's pick one. I don't know. Let's don't pick anything super hard, but 5, 5. Well, I don't know. 5, 5's on there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5's not on that side. Negative 5, 5. Okay, that'll work. 1, 2, 3, 4, 5. Yeah, so if we pick negative 5, 5. So let's put it in there and let's see if that works. So what is the y then? If I pick negative 5, 5, I'll write it down here. Negative 5, 5. What is the y? It's the 5, isn't it? I'll put a question mark here because I don't know just yet. Then put in the x. What's the x? Negative 5 and then plus 2. Okay, 5. Is 5 less than negative 3? It's not. I'll put this. Okay, it's not less than or equal to negative 3. So I am not shading anything over here. So how do I show the shading? I just kind of do this. You don't have to shade like every inch of it, but we'll shade a good portion of it. All right, that's pretty good. Gives you the idea. All right, and that's the shading. So what does that mean? That means anything either on the line or in the shaded part will work for that inequality. And everything that's not shaded will not work for the inequality. If the line passed through 0, 0, you know it would work because any point on that line would work. Like if I pick this point right here, 1, 3, that point right there, okay? That's actually on the line, isn't it? But that's not going to help me with my shading, though. If I pick a point on the line, that'll always work, right, if it's or equal, okay? But what I'm concerned about is not a point on the line. I'm concerned about other points that are not on the line. Any point in here that I pick on this side of the line will make this thing work, right? Let's say I pick that point 1, 3. So y is 3. This is 1 plus 2 is 3. Is 3 less than or equal to 3? It is, because it's what? It's equal to it, right? It has to be either less than or it can be what? Equal. So any point on this line, so if that line went through 0, 0, what if it was just like, I don't know, y is less than or equal to x, right? That would go through 0, 0, all right? So I would have to pick something below that line. So I wouldn't put 0, 0 in for that. I'd put like 1, negative 1 or something, okay? I wouldn't put in a 0, 0. Now, the only reason I put in 0, 0 because it's super easy and it's below the line. Everybody got me? Okay. Once you get that idea, the rest is really not so bad. We only got 2 more examples. Let me copy this graph. Put it here. So we got 2 more to do. This one's pretty close to what we just did, but they make it look pretty fancy. Remember that domain and range thing where they say x such that x is whatever? Okay, that's what we're going to do. And they write like f of x. That's what we're going to do. Actually, they don't say f of x. It just says... I don't know why they say graph. Anyway, here's what they do. They write it like this. Okay, you're going to graph x and y, the points x and y, such that 3x minus 4y is less than negative 8. It's the same exact thing that we just did, except they make it look a lot fancier. They're just trying to get you used to that notation. All right, don't let that notation fool you. Really, the only thing we care about is this right there. Everybody understand that? Okay, the rest is just kind of window dressing, just makes it look nice and pretty. Okay, so let's write it. So we're going to graph this thing. First thing we need to do, though, before we graph it, is put it in slope-intercept form. Okay, that's the easiest way to graph. So let's do that. It's the same exact thing that we just did before, just the numbers are a little different, that's all. Subtract a 3x from both sides. So I'm going to put it over here, make it a minus 3x, negative 3x. Divide by negative 4. I think I will show this time. Now we divided by negative. So what do we have to do? Change the direction. So it was less than. This time it's what? Greater than. This is positive. Negative over negative is positive. So that would be 3/4 x. And then this is going to be plus 2. So this is what we're going to graph. Everybody should be used to that by now. What's the one glaring thing that you see about this that's different than the last graph we did? Say it. Okay, the fraction, but that just is a slope. That's not that big of a deal. It's not or equal to, right? So what does that do to our graph? Makes it a dotted line. That's right. Okay, so as soon as I see that, I'm thinking, oh, okay, it's got to be a dotted line. So I'm not going to do a solid line. Okay, so let's graph the thing. Y-intercept is 2. Slope is 3/4. So I'm going to rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. And I could do another one. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. All right, that's good enough. Let's do one more. 3, 4. Goes all the way to here. Do you agree? All right, now I'm sure there's a way on this program where I can actually draw a line that's dotted, but I haven't figured it out yet. I really haven't put a lot of time into researching it. One day I will, but I'll just do it by hand. There we go. That's good enough. Goes like this, keeps on going like that. There's my dotted line. Well, what am I missing? The shading, right? I got to shade. I got to decide which way am I going to shade. It does say greater than, doesn't it? All right, so just off the top of your head, where do you think you're going to shade? Above, right, on the top of that line, above that line. Again, let's say you forget, all right, or you don't really know which way I should shade. Should I shade below or should I shade above? What can you do? You can always pick an easy number. Let's pick the 0, 0. That'll be good, all right, and make it easy, especially since we have a fraction here. All right, let's put 0, 0 in. So 0, let's see if it's equal to, I'll put a question mark above it this time. So is 0 less than this or greater than this? Well, what's 3/4 times 0? 0. That's why I picked 0. It makes it super easy. Would you agree? Yeah. And then plus 2, which is 2. Is 0 greater than 2? Of course it's not. So do I shade where the 0, 0 is? No. So where am I going to shade? On the other side. So this is where I'm going to shade. Does that make sense? If it doesn't, let me know, and I'll try to maybe explain a different way, I guess. I don't know. So that's how I'm going to shade, and that's my graph. So it must be a dotted line. All right, if it's not dotted, if you put a solid line there, it's going to be wrong. Even if it's going in the same direction, even if you did your math right, even if you did your shading right. If it's not a dotted line, it's going to be wrong. Obviously, if you shade on the bottom of it instead of the top, that'll be wrong. And of course, if my line doesn't go through the right y-intercept and have the same slope, it'll be wrong for that as well. All right, so make sure you get all three of those things right, and you won't have any problems with this. Is that helpful? Okay. Let's do one more and we'll be done. Not too bad, is it? You feel good about this? Being on the quiz? Yeah. Would we just finish graphing that you hadn't really graphed before? What is it? Well, we're doing that right now, but before today, before we did these inequalities, what were we learning how to graph that you haven't? Absolute value, right, the absolute value stuff, okay? So that's what they're going to do right here, all right? We got to figure out where we're going to shade with the absolute value. Sometimes that gets a little tricky as well. All right, so let's do it. This is example 3. The other is example 2. I don't know if I wrote that down or not. Now this one, they don't give it all that fancy notation. They just do it like this. This would be good practice with that absolute value. Okay. So let's, first of all, you got the absolute value, so what kind of shape is our graph going to look like? A V, right, it's going to look like a V. What do these numbers do to that V? What does that plus 1 do to it? That moves it up 1, okay? Now, this is the tricky part. What does that one do? Remember, it goes in the opposite direction. Remember, this is x minus a number plus another number, okay? So this, the 2 is actually a positive h. Does that make sense? But our equation says x minus whatever the h is. So the h, so this is actually, I know it looks like a negative 2 because it's minus 2, but the h is actually the 2. So that means we go to the right 2 places. Everybody with me? From where? Well, from the origin. Because if those things weren't on there, if it just said y is equal or greater than just x, we would start at 0, 0, wouldn't we? But we're not going to start at 0, 0. What are we going to do? We're going to go up 1 and to the right 2. So that's where the V is going to start. That's the vertex of the V. In fact, if you wanted to write it like that, you would write it, where is that point? It's at 2, 1, isn't it? Everybody see that? We're going to be doing stuff later on when we do some more complicated graphs where we're going to talk about the vertex. I should have wrote vertex. There we go. Vertex is 2, 1. So that's where it starts. Now, this just goes up 1 over 1. Right here, 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 and you keep on going. Then it goes to the left 1, up 1, and so forth. Now, is this going to be a shaded or dot, or not shaded, sorry, a solid or a dotted line? It's dotted line. How do I know it's going to be dotted? It doesn't have an or equal to it, right? All right, so I'm going to put a dotted line like this, and a dotted line. Oh, it's a little harder to do it that way. There we go. And I'll just keep on going like this. All right, but I'm not finished though, am I? Because it doesn't say equal. What does it say? Greater than. So where do you think the greater than part is? Is it like inside of here or is it outside of there? What's your first gut instinct? Yeah, it's probably inside of here, isn't it? Well, let's see if it really is or not, okay? Let's just not go with our gut. Let's put an actual number in. Now again, there's a number sitting right there that's super easy to use. Which number would I pick? I would pick 0, 0 again. Why? Just because it's easy. That's the only reason. I could have picked a number that was inside of here, up here like this. I could have picked a number way down here if I wanted to. But 0, 0 seems to be the easiest number to pick. So that's what I'm going to choose. All right, so let's put them into this little equation right there. Let's do it in white. Got too much red going on. All right, so 0, 0. So that would be 0. Put it greater than. I'm going to put a question mark on top of it because I'm not really sure yet if it's going to be greater than or not. All right, and then put absolute value. X, which is 0 minus 2. It's an absolute value. And then a plus 1. Let's do the math. Again, I'll put a question mark here. This is the absolute value of negative 2. What's the absolute value of negative 2? Positive 2. And then 2 plus 1 is 3. So is 0 greater than 3? No, it's not. So do I shade in that region right there? Do I? No. So where am I going to shade? well, inside the V. And that's where my shading's going to go. And that's all there is to it. That's the only thing really different that you got to know about inequalities. It's really not that much different. I mean, the graph looks crazy different. It's got all that shading in there, and then you got dotted lines, whereas before we always had solid lines. Okay. But you know, besides that, the actual graphing of the graph isn't any different than what we've done before. It's just you got to know if it's shaded or solid, and if it's dotted or solid. I always keep mixing that up. And then where you shade it. All right, that's the only thing different. And there you go. So that means, what does this mean? It means any point in this area right in here will work for this. Any point outside this area will not work for that. That's what it's telling you. So these are all your solutions. There's a whole bunch of them. In fact, there's an infinite number of solutions. All right, but we show them by the shading. And that's it. Any questions on this? Everybody good? All right. Gave you time to ask some questions. So let's do a little homework here. Section 2.6. It's pages 90 and 91. And it's numbers 9 to 25, but I am only giving you the odds this time. Isn't that nice of me? A little more enthusiasm where I could give you all of them. No. Oh, okay. Now you're grateful. All right, so there you go. 9 to 25, you're only doing the odds, and section 2.6. So I need to see graphs. I mean, my guess is, I don't have the book out in front of me, but my guess is every one of these is going to be a graph. That's my guess. All right, so make sure that you do that. If you have graph paper, great. If not, use a ruler, okay, to draw it. I'm getting such sloppy stuff. Not necessarily from your class. I'm thinking probably more my pre-calc class, because they had a homework they had to do. I mean, I'm getting this. I'm getting like this, like that. I'm getting stuff that looks like that. There's no numbers on here. There's no nothing. It just looks sloppy. All right, it's not accurate. All right, you can use graph paper if you have it. If you don't have it, you know, use rulers. Try to make sure these points are evenly spaced. If you have a ruler, you can do that. Okay, and make sure you use a ruler to, okay, make it look nice. Be proud of your work. Everybody good? All right.